Hello friends, this is a third video lecture where I am showing the errors in the Lorentz transformation. So this is the video for error in time dilation. Actually there is no error, there is no time dilation. So I'll take you through the explanation how there is no time dilation in moving frame of reference. So in video 1, I have shown that there are 4 errors in the position equation of Lorentz transformation. Same errors are also there in the Lorentz equation for time dilation or time. Same errors are there. You can go through video number 1. It's the equation for time dilation also suffers the same errors, 4 errors. So you can go through it. I am not going to explain it now because the position, this x, this is the position in position equation, and this x is also here, so it will suffer the same issues where this equation and this equation will suffer the same issues, that is errors. Now derivation of time dilation. So what they have done is they have taken these two equation of positions, that is forward transformation and reverse transformation, and they have derived these two equation of forward transformation of time and reverse transformation of time. Right now these two equations suffer from errors. I have shown it in video number 2. Kindly go through video number 2. So time being, we are considering they are true, but they are not actual sense. So what they have done is they have taken this reverse transformation equation, they put it here, then they brought this value of gamma, the denominator of gamma here this side, this is the thing, then they have put the value of x prime from the equation number 10 to here, then they solve it, then they got this, they removed the value of x through cutting from both the side, and then they got this value, this and this equation. So they have done nothing much, just inserted the value of x prime by using this equation and solved it. You can go through it. Solution is very simple. This is for reverse, this is for forward transformation of time, the reverse transformation of time. What it says is that the time and moving frame of reference will increase, the duration of time will increase, but I will prove it to you that duration of time in moving frame of reference will not increase. So first let us see the Galilean transformation of time. Galileo has given this, maybe he is not able to understand, but he has given the right equation, that is t prime is equal to t rest. Whatever is the time duration in stationary frame of reference, that's the time duration in moving frame reference is also same. But looking at the equation of position, this is the equation of position, x prime is equal to x minus vt. So he should have applied mind and given this equation actually, but he is not able to understand. See, this in this equation x prime, you have to find x prime, this is x prime. So to find x prime, you take the value of x. So this is what they have done. He had done is found the value of x from here, and then it's subtracted from Vt. This is your Vt from here to here, and you got the value of x prime, right? So what he has done is he has calculated the value of x by experimenting. The probe is sent from this stationary frame of reference to point P, but point P is transformed. The probe will come here and return back. So they will find the distance, right? Similarly, you can use the same concept, or he would have used the same concept for time also, because the light will go here and come back, so it will take some time, so double the time will come. So you make half of that, it becomes t, so it will be, first they will get 2t, divide by 2, you will get t. This time they can easily get, so this is the time x and t minus this d upon v, minus d upon v, and they would have got this equation. But fortunately, he has not used this equation, this concept he has not used, so he has given this. And this is the right one. Actually, this equation is wrong. Right? So he has given a right equation, that is t dash is equal to t is equal to t dash. There is no change in time dilation, change in time. So there is no time dilation. Now, next, now time dilation in Lorentz transformation. So Lorentz has given this equation. I have already derived the equation for you. So this is the equation. Now what happens? Let us see. In this equation, if we see here, if this frame of reference and this frame of reference are, say, this frame of reference is at rest, and this frame of reference, that is S prime frame of reference, is crossing this frame of reference, right? Once it is crossed it, just crossing it, where the O and O prime coincide, that time what happens is there is one flashlight in both the this and this, both the, from both the origin one light flashes, right, and it moves away. Now what happens, this one and this frame of reference light will go to P, and it will, there will be some time, so it is T, right? But when this frame of this observer from this frame of reference finds that this light has reached from P to P dash, it has to reach P dash, so there will be increase in the time duration, because this observer will check here and here. But the problem is, this origin O prime has changed from O prime to O1 prime. So this, when it crosses through, actually it is here, but he may find it is here, but the real position of this is here. So this, the observation of this observer from this frame of reference is wrong, because at velocity v this transforms to this position, O prime to O1 prime position. Therefore what happens is the time duration will be measured from here to here only, and this time duration will be this t1 prime. So when this t1 prime is compared with t rest, they are both equal, because this transformation from P to P dash will be equal to transformation O prime to O1 prime. So the time duration will be same. So there will be no time dilation, right? Now there is a shift. There is always a shift because this shifted. So how the time has shifted? Time has shifted, but there is no time dilation. Time dilation same, but time has shifted from here to here. So how can you explain this shift? So I got a very good example of airlines wherein Bombay to Heathrow, that is London Heathrow, this flight starts at 14 hours and it reaches Heathrow at 19 hours. Right now, if you check that is local time, these are local time. So local time 19 minus 14, that is 5 hours. So we may think that is 5 hours, but when you find that the flight has taken 9 hours 30 minutes, so these are only the local time, but flight has taken 9 hours 30 minutes. So 9 hours 30 minutes is the time duration. It is same every time, but local time, because of local time, we will find the time flight has taken 5 hours. So this is shifting. This 5 hours is shifting. It shifts one side, and while returning, it shifts other side. Similar to this, when this moves in this direction. So now see here, the flight from Heathrow starts at 9:50 in the morning and reaches 23:40 hours Mumbai. The flight by local time has taken 14 hours and 10 minutes. But when we check the duration of the flight, it is again 9 hours 20 minutes. Got? So what is happening? The duration is same. Duration is same, but because of the local time, the time has shifted. Time has shifted, and this has shifted to 14 hours. That is, this is increased. And when you compare from here to here, the time will decrease. It has shifted to this side. So this is a very good example. There is no time dilation, only there is a shifting of time. Even the mass gets shifted, there is no increase in mass when the motion is there. There is no increase in mass. Right? That I'll explain to you in another video. I hope you have understood all this. So my email ID is given here. Any any suggestion, you can send it to me. You can also send some criticism. If you find my explanation right, kindly forward it to professors who are very good, who are expert in general relativity. And if my theory is right, then we will go ahead to give an updated general theory of relativity. So these are my references. Thank you so much. We will meet in the next video.